All right, hey Ninja Warriors, welcome to yet another power packed session. And today we are going to start and finish complete integral calculus for your upcoming examination EAPCET. Right? So last time we did differential equations and today we are doing basically last time we did differential calculus and today we are doing integral calculus, right? And I saw your comments on that video wherein you were asking that, ma'am, not just solve questions but also teach concepts, also teach the concepts behind the questions as well. So today's session is all about concepts linked and previous year, basically recent year questions of your EAPCT examination. Very effective session, right? Very crisp, very short, but very effective session, okay? We'll be revisiting all the concepts which are linked with your recent year questions related to complete integral calculus, and along with that, of course, recent year questions we are going to solve. Are we ready? Please let me know in the chat box if we are ready for it, if you are ready to commit next 1.5 hours with me, right? We'll try to finish the session in 1 hour, approximately within 1 hour or 1 hour 15 minutes, plus minus 10-5 minutes you can do. Okay, all right. And also please let me know in the comment section that I am perfectly audible and visible as well or not. Yes, keep joining, keep coming, and right, keep liking the session and keep sharing the session with your fellow EAPCT aspirants. Okay, so without any further ado, let us start. So in the beginning, we'll be discussing some concepts in one go, and then we'll be start solving questions related to integration, definite integration, differential equation, right? Okay. Okay, so first of all, integration, let us understand. You all know that integration is what? Reverse process of your differentiation, right? So sometimes in EAPCT examination, you don't really have to integrate something. What you can do is you can just figure out by the options that if I differentiate the option, I'm gonna get what? I'm gonna get the question. Okay, so this is very important, very basic but important information, that integration as the inverse process of differentiation. Okay, that is one thing. And we are going to discuss properties of integration, method of substitution. This is very important. So you have to substitute something. This is very popular and important as well, frequently asked. And integration of algebraic, exponential, logarithmic, trigonometric functions. Okay. All right, yes. So this is what we have. We are having fundamental formulas of integration that you must remember. Otherwise, you won't be able to decode any question if you don't know the basic formulas, right? So tan x, the integration of tan x is what? Minus log cos x. Please remember this. Or what you can just do it. So this is log of mod of sec x is also there. So basically, many of the students remember this formula. Tan x integration is log of sec x. Very important. Log of sec x can be written down as minus log mod cos x. Okay. All right. Then we have sec x integration. So log of sec x plus tan x. Then we have cosec x integration, log of cosec minus cot x. And then these are the few similar type of integration. 1 upon square root a square minus x square. Right. So that would be sin inverse x by a. Please remember, I always tell you this. That in sin inverse formula, there is no 1 by a in front. But in tan inverse, you can see 1 by a is here. So people usually get confused, and they always in the question, be it your VIT be it your EAPCT examination, they will give you such question wherein you get confused whether there was 1 by a or not. Right? So basically, please remember this. Okay? These two formulas, and we are having 1 upon x square minus a square. So this is 1 by a sec inverse. So only sin inverse is not having 1 by a, except sin inverse. Every formula will be having 1 by a. This type of formula I'm talking about. So I hope you can take the screenshot. You can just have a look and you can just understand what are these formulas. Now next, again, very important formula. So okay, can you see these two formulas? Okay, let us talk about these two formulas. 1 upon a square minus x square, 1 upon x square minus a square, right? So I won't recommend you to remember this formula, okay? Because these two formulas are exactly same. Remember only one formula. Because if you get a square minus x square, what you can do is you can take out minus sign common and you're going to get this, okay? So I always remember this formula, 1 upon x square minus a square, and it start with minus sign. See, minus minus. We are going to use this formula in today's session. We are having a question related to today's session. Okay. All right. Next, we are having 1 upon root x square minus a square. So log x plus copy paste. Again, log x plus copy paste. Can you see? Now this is something different. Square root a square minus x square. So this is exactly similar to sine inverse. Can you see? Sine inverse is used because this is in numerator now. This is also in numerator. So this is log of x plus x square minus a square over here. And you can clearly see that these two are exactly copy paste. 1 by 2x copy paste. Okay. And we are having square root x square plus a square integration. So this is the formula. Have a look at all these formulas so that we can apply it nicely. Okay. All right. Yes. Now substitution method. Okay. And I know that sometimes we just tend to forget formula here and there. So I'll be reminding you, I'll be revising you all the formulas gradually, step by step, so that you don't forget it. Okay. All right. At one go, it is very overwhelming to remember all those formula. I understand that. Okay. All right. So just try to remember maximum as much as possible, and I have marked the star that okay, these are the formulas that you should remember. Okay. I agree that 1 or 2 formulas like this you just might not feel like recalling at certain moments, but I will make sure that I will remind you in a regular interval. Okay. Now substitution method, very easy. What we need to do is, so suppose we are having integration of this form, f of g of x, g dash x, right? So gx, if I substitute t, g dash x dx will become dt. So this is nothing but f of t dt. Can you see? F of t, this is t and this is dt. So f of t dt integration. So that's how you integrate by substitution. Very important, very popular. We are going to use this method throughout the session. Okay. All right. Now, this is actually very important. So the moment you see a square plus x square, a square plus x square, that means x should be a tan theta or a cot theta. Okay. All right. Why? So now I don't want you to remember it. It is very quite intuitive. So you have how many ratios? Tell me. Sine cos 10, cos x sec cot. Okay. Let's talk about 3 primary ratios. Sine cos 10. If you put a sine over here, so 1 plus sine square will not make any sense. 1 plus cos square also will not make any sense. Only a tan theta, 1 plus tan square theta is sec square theta. That will make sense. That's why this. Okay. You don't have to remember. It's quite intuitive. It's quite conceptually. Okay. A square minus x square. Now, if you put tan theta at the place of x, what will you get? A tan theta. So, why a square minus a square tan square theta? No, no, no. Why? 1 minus tan square theta is nothing. But 1 minus a square sine square theta will work. A square minus a square cos square theta will work, because 1 minus sine square, 1 minus cos square will make more sense. So that's why either a sine theta or a cos theta, anything will work. So that's how you put. Okay. Now x square minus a square. So the moment you put sec theta or cosec theta, that will work, because sec square minus 1 or cosec square minus 1 will give you tan square or cot square respectively. Okay. All right. Now next, now can you see, especially this, when both minus and plus are together, then you are confused. Ma'am, a minus x is also there, a plus x is also there. Now what do you want us to like substitute? So that would be a cos 2 theta, right? Because 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta also we have formula 2 sin square theta. So whenever you see plus and minus, you apply this formula. Okay. And this is actually very rare. You will get this very rare when you see x minus alpha and beta minus x. So one is x minus something, another one is beta minus x. So you have to put alpha cos square theta plus beta sin square theta. Very rare. So you can just skip it for EAPCET and VIT examination, right? Because if this type of question, even if it is there, it will take you a lot of time to solve it as well. You know how integration questions sometimes are. Okay. Now let's talk about differential equation. Yes. Okay. Completed algebra. Yes. Got it. All right. So now definite integration. So in definite integration, definite integral as a limit of sum. So this we did in limits chapter actually, because this question is what we call as disguise. So the question looks like the question is of limits, but no. The question is of integration, right? Okay. Now interpretation of definite integration as in area. Yes, area under curve. And then we have integral calculus fundamental theorem, properties of definite integration. Let's start with properties of definite integration, okay? So properties, the very first property is what? So you know indefinite integration. Indefinite integration may you have to apply what? Constant of integration, right? But in definite integration, you don't have to apply constant. Rather, what you need to do is there is upper and lower limit. So this is what we call lower limit. This is what we call upper limit. So integral from lower to upper. So what we do is we integrate it first. We get the answer in x, right? And then we put upper limit. We apply minus sign. We put lower limits. So that's how we integrate it. Okay. All right. So this is the basic thing of what? Definite integration. I hope that this is clear. Once we apply, this will be more clearer. Okay. Let's just go through all the properties of definite integration. Now, one by one, very basic property. The very first property says that, okay, indefinite integration, the answer of indefinite integration is a variable, right? The answer of indefinite integration is a variable thing. It depends on the variable, either x or y. But the answer, the result of definite integration is a constant value. So this will be a constant value. Whether you integrate it with respect to x, then also you will get the same result, or you integrate with respect to t or y or a or u or w. So all these will be equal. So variable, change of variable will not make any difference in definite integration because the final result is a constant value. I hope that this is clear, very basic. Now this, whenever you see a to b, and if you feel like why I don't change the limit, upper limit should be the lower one, lower limit should be the upper one. So if you want to do that, you have to realize that the minus sign should be out. So a to b will be equals to minus of b to a. All right. Now a to b fx dx. Clearly we can see over here. Now this is where we break the limits. Yes. So can you see that here we are integrating our fx from a to b. From a to b. But what if I want to break the limit in between a and b? So suppose 1, 2, 3 you are doing and I want to cut or break the limit at x equals to 2. So 1 to 2, 2 to 3. So that's how it is. A, b and c. So first of all, here we are going from a to b directly. But what we can do is we can break the limit. First we will go a to c. Can you see a to c? And then b to c. C to b. A to c, c to b. So rather than going directly from a to b, what we will do is a to c, c to b. This is the breakage of limit. When do we break the limit? When do we break the limit? When our function is discontinuous at x equals to c, or what we can say is our function is differently defined in a certain interval and differently defined in the certain interval. Okay, all right. Yes, definition is getting changed basically. Yes, Ali Badai is saying 0 to 2 pi means what? 0 to pi, pi to 2 pi. 100%, absolutely. Now properties of definite integration. So properties of definite integration, very important. One more property is King's property. This we have studied in JEE Main as well, and we have studied shortcut related to this property as well. Do you remember that shortcut? So first of all, let's understand what is the King's property. So King's property says, suppose you have this integration a to b fx dx, right? Now this x will get replaced by upper limit plus lower limit minus x. Array. X will be replaced by upper limit plus lower limit minus x. So can you see this x will get replaced by a plus b minus x. Okay, this is your King's property, right? Now this is the result which we have obtained from King's property. What is this result? Let us understand. So over here, a to b, f of x, this is your integration. F of x plus f of a plus b minus x is what you need to figure out. Okay. So let us suppose this is your I. Now what I'll be doing is, this is first equation. I'll be applying King's property. That means this x, both the x and also this one as well will get replaced by a plus b minus x. So this is going to be f of a plus b minus x. This x will get converted into a plus b minus x, right? Plus a plus c. X gets converted into a plus b minus x. Now a plus b minus x will get converted into x. So this integration after applying King's property became this, like this. Now can you see the denominators are same? Fx plus f of a plus b minus x, fx plus f of a plus b minus x. So whenever we see denominator same, here is the opportunity. Why don't we add it? So 2i is equals to, the moment you add it, what do you get? F of x plus f of a plus b minus x. And this is f of, if you add f of x plus f of a plus b minus x, right? This is dx, integral is there, a to b, that's it. Can you see? Both will get cancelled out. Only one will be there. Integral of 1 is what? So x, integral of 1 is what? X, upper and lower limit a to b, and this is your 2i. So this is b minus a upon 2 is your I into I. So b minus a upon 2 is your shortcut. This is the proof of the shortcut. You don't have to solve it. Okay. All right. Clear? B minus a by 2. Right. So this is your shortcut. Clear? Now same. Can you see this is mini King's property? Oh, am I stuck? I am stuck, right? Okay. Let me yeah. Yes. Okay, it's fine now, I guess, है ना? So I guess this shortcut is clear. I am clearing this. Okay, let us now talk about the mini King's identity or mini King's property, wherein your lower limit becomes 0. So here x will be replaced by what? A plus 0 minus x. So that will be a minus x. Quite intuitive, same thing, right? Just the values are different. Okay. And now minus a to a. This is very important, even odd property. Minus a to a fx dx. If you wish to integrate it, right? So that actually will be twice of 0 to a if your function is an even function. And if your function is an odd function, then it's very good, because we are going to get 0. And if we are getting 0, no need to integrate, right? So please pray every time, okay? Please be the odd function, don't be the even function, because even function will have further more work to do. Odd function will be very easy. Hai na? All the lazy people out there, what will you pray? Please, the integration of odd function should be there, minus a to a, and we are going to nail it. Okay, so odd function 0, but even function we have to double it the 0 to a fx dx, and then we have to integrate it. Okay, all right, yes. Okay, now the periodic property. So periodic property, very easy property. So let me just tell you the first of all the basic property. 0 to nt f of x dx. Suppose we have a function whose period is t, fundamental period is t, okay? And you have to integrate from 0 to nt, just like mod sin x. Let us understand mod sin x. What is the period of mod sin x? Pi. And if I wish to integrate 0 to 100 pi dx, right? So 0 to pi, whatever you get 0 to pi, you are going to get from pi to 2 pi as well, 2 pi to 3 pi. So why don't you integrate 1 times 0 to pi and multiply it with 100? So 100 multiplies 0 to pi, mod of sin x dx. And now you can just go ahead and integrate it. If you're going to integrate it, what you're going to get is 200, I guess. 200 will be the correct answer, right? Okay. So again, same thing. So this time period is t and n is the cycle. how many cycles you're having. So n will come in front, 0 to t f of x dt. Now you can just go ahead and integrate, right? Yes, okay. Yes, Hobo, yes, I have read your comment. Yes, I have read your comment and I'll keep that in mind. I will be bringing each and every unit wise, I'll be bringing the sessions, okay? All right. Now, yeah. So now A, starting from A plus NT. So A and A will get cancelled out. So it will be 0 to NT only. So it is same thing. So this is same, right? A, you can cancel this out. Okay. I hope that this property is clear. If it is not clear, we'll solve the question and then you will be understanding it. Okay. All right. Now, very important. I have made a video on this as well. Right. It was deleted from your JEE main, but they anyway gave in January JEE main attempt. And I made a video on this definite integration as the limit of a sum. Okay. So, let's understand this now. So, suppose let us understand with the help of a question. So, suppose they are giving 1 upon n. Okay. And what they are giving is limit n tend to infinity, sigma k is equals to 1 to n, and yes, so this is, let's say 1 upon n plus 2 upon n and all the way up to n upon n. Very simple. Well, let's take very simple example. Okay. So this is what you need to calculate. The moment we see, so we see limit n tend to infinity. So what we feel is, okay, this is a question of limits. No, no, no. But limit is there of a sum. Can you see limit of a sum is there? Right. So we need to the screen is getting stuck. Okay. Yes. All right. Now, understand this. So you have to, so limit n tend to infinity is there. So limit n tend to infinity, this 1 by n. This 1 by n will be replaced by dx. This 1 by n will be replaced by dx. So this 1 by n I will be writing as dx, right? Next, sigma f of r by n. Right, f of r by n. So I need to convert this in f of r by n. So basically, let us remove the sigma. Actually, I have applied sigma as well. I have applied sum as well. क्या हो गया ये? Why am I not getting toolbox? Is it going to appear downwards? Pointer options, eraser, है ना? So let's just remove it. Pointer options, pen, huh? Right? So can you see this? Now I can convert this. So 1 upon n, limit n tend to infinity, and this is going to be sigma of r by n, where r starts with 1 to n. So basically 1 by n will be replaced by dx. Can you see r by n? So this r by n will get replaced by x. So this is x only. And integration will be 0 to 1. How? So r by n clearly is, can you see x? R by n is x. The moment you put r equal to 1, what do you get? 1 by n. 1 by infinity is 0. So that's why 0. The moment you put upper limit n by n, x is going to be 1. So x square by 2, 0 to 1. So 1 by 2 is the correct answer. Okay. All right. Okay. Clear? Yes. So that's how you solve it. So you just have to remember that r by n will get replaced by x, 1 by n will be replaced by dx, and how to calculate limit is very important. Okay. Yes, VIT, VIT, one more session. No, not one. I'm gonna give you more sessions. Do not worry about it. Okay. All right. Let us now focus on this question which was there in EAMCET 2020, and this is from King's and Queen's property both. Shall we start solving questions from integration at least? Yes. Okay. Questions? All right, so the very first question, let us start solving it. First of all, this question was given to us, which is what? 0 to pi x f of sin x dx. This is your I. I have always told you that whenever you see definite integration and algebra and trigonometry, if you get together, algebra and trigonometry both together, then what you need to do is you need to apply King's property. So here x will get replaced by pi minus x. Okay. So let us do that. I will be equals to 0 to pi minus x, and f of sin pi minus x is sin x only, so f of sin x. If you add, after applying King's property, most of the time we are going to add. 2i will be equals to 0 to pi. This is pi, this is 0. Okay, and x f sin x minus x f sin x. Can you see, if you add these two, x f minus x f will get cancelled out. This is f. Okay, so what we are going to left with is pi times f. So pi times f of sin x dx. Right, this is your 2i. Correct? So I will be equal to pi by 2. Let's take it outside. 0 to pi, and this is going to be f of sin x dx. Right? Yes. Now, if I look at the answers, no answer I can see which is there in 0 to pi. Right? I can't see any answer which is there in 0 to pi. So I have to change the limit. For that, Queen's property will come into the picture. Let me tell you the Queen's property, which says that f of x dx 0 to 2 pi, 0 to 2 pi will be equals to f of x 0 to a. Can you see, I am changing the limits, plus a to, okay, 0 to a f of 2 pi minus x. Sorry, 2a minus x dx. Yes, this is your Queen's property. That's what we are going to apply. Let us understand this. Let us understand this property. So this property is applicable when you need to change the, kya ho gaya ye? A. So this property we will be using when we need to change the limit. So can you see, 0 to 2a is converted into 0 to a. Right? 0 to 2a converted into 0 to a. That's what we want. We want 0 to pi to get converted into 0 to pi by 2. So let us apply this property. So here 2a and pi are same. So this is going to be pi by 2. Let us keep it outside. So 0 to a. So 0 to half of our main limit. F of x same. Plus again 0 to pi by 2. 2a minus x. What is 2a? This is 2a. Pi is my 2a, right? This is 0 to 2a. Pi is my 2a. Pi minus x. So sin pi minus x. X will get replaced by pi minus x. You tell me sin pi minus x is sin x. So this is f of sin x only. So you can just simply add these two. So pi by 2 on this is going to be 0 to pi by 2. 2 f of sin x dx. 2 cancel, and okay, so this is wrong. This is also wrong because 0 to pi by 2. So we can clearly see that pi times 0 to pi by 2 f of sin x, option D is absolutely right. Okay, let me show you the answer one more time, the solution. So this was your integral, algebra and trigonometry together. So what we did is we applied King's property first. So King's property, the moment we apply King's property and add, what do I get? I get this. Okay, I get this. Yes, this is what we got after applying King's property. Okay? All right, now after applying King's property, what we can do is we can just simply apply this. 0 to 2a fx dx will be this. Okay, same Queen's property that we applied, and we are going to get I is equals to pi times 0 to pi by 2 sin x. Okay, all right. Yes. All right. Okay. Now we are having a question wherein, yes, so it is related to tangent and normal. So in previously, I couldn't keep this question. So this is from differential calculus. So I just picked that question from differential calculus and fitted in our complete integral calculus session because I found it really important. So the number of points on the parabola at which the slope of the normal at the point is equal to x coordinate of that point. Very easy question, but I found it really good. So what they are saying is slope of the normal is equal to x coordinate. So let us first find slope of normal. How to find slope of normal? By actually taking negative reciprocal of slope of tangent. So why not we calculate slope of tangent by differentiating 2y. 2y y dash is equals to 1. So can you see y dash, which is slope of tangent. So this is your tangent. Slope of tangent is 1 upon 2y. Slope of normal. So slope of normal will be what? Minus 2y. This is your slope of normal. And minus 2y will be equals to x coordinate. So this is what we are getting on the curve. So this curve and this should be y square is equals to x and x equals to minus 2y should be solved together to get how many values of x comma y we are getting or how many points we are getting. So y square will be equals to minus 2y. Can you see y getting cancelled? That means y is coming out as 0 and another is y is minus 2. The moment you put y equal to 0, you get x is also 0. So 0 comma 0 is the one point where it is happening, the condition. And the moment you put minus 2, so 4 comma minus 2 is the another point. So 2 points, option C, absolutely right. Okay. 2 points are there, 0 comma 0 and 4 comma minus 2. Okay. So if you are here and you haven't liked the session yet, what are you waiting for? Like it right away. Okay. Yes. Clear? So yes, these are the 2 required points. So option C is absolutely right. Now this question is from 2023 EAPCET examination. Recent questions. So your demand was the same, that ma'am please solve 2023 problems. So from now on, what we are going to do is we are going to solve 2023 problems. So now on this note, I'm gonna deserve a like. Okay, on this note, I'm gonna deserve a like. So please like the session right away. Okay, so this is from 2023 EAPCET examination. Let us understand this question. This is from integration. F of x is equals to x upon this. For n greater than, what we need to figure out is this. Okay. So what we will do is we'll plug in the value of fx from here to here. That's it. Let's do that. Okay. So x raised to power n minus 2 fx. So this is your fx. 1 by n. And integration is there. Dx is there. Okay. All right. Yes. So now can you see x raised to power n minus 2 into x raised to power 1. So this can be clubbed together. So x raised to power n minus 1 dx upon 1 plus n x raised to power n raised to power 1 by n integral. Right? Okay. Now how to integrate it? So first challenge of mine is this power 1 by n. So whenever you see power 1 by 3, 1 by 4, 1 by 2, what do you do is, if you see power 1 by 2, you put t square. If you see square root, you put t square. Power 1 by 3, t cube. So if you're seeing power 1 by n, what I'm going to do is 1 plus n x raised to power n can be written as t raised to power n. Right? So that's why this whole quantity will be t raised to power n. And this power 1 by n, so this is what your t is. So this is your t. The whole thing is your t. Right? So this denominator should be t. So that I get rid of this 1 by n. Now differentiate. The moment I start differentiating both the sides, 1 ka derivative is 0 plus. N will come in front. N times n x raised to power n minus 1 dx. And on the right hand side, n t raised to power n minus 1 dt. N getting cancelled out. So this x raised to power n minus 1 dx will be what? This will be t raised to power n minus 1, okay, dt, whole upon this n will go over here, and this whole denominator was what? T, right? So this is what it is, and this is going to be 1 upon n t raised to power n minus 2 integration dt. So this is going, if I integrate, very easy, this is very easy to integrate, 1 upon n. So integration of this is t raised to power n minus 2 plus 1. So n minus 1 upon n minus 1 and plus constant of integration. So this is your final integration. Now you have to plug in the value of t over here. Let's do that, the final thing. Although I have got my answer, this is n, this is n minus 1. So this option 1 is absolutely right. But still, I will do that for you, right? I will do that for you. The option A is absolutely right, okay? No, we are confused, yes. So the moment I saw n minus 1, either A is right or C can also be right, n minus 1. So we have to be very sure that 1 minus 1 by n is there or 1 plus 1 by n is there, right? We have to be very sure in these two things. So let me just write down over here what was the answer. So 1 upon n and 1 upon n minus 1 was there. Let's copy it out. T raised to power n minus 1. So t raised to power n minus 1 plus constant, and remember t raised to power n was nothing but 1 plus n x raised to power n. That's it. Hai na? Now let us calculate the value of t. So value of t is what? 1 plus n x raised to power n raised to power 1 by n. Right? So this is what? T raised to power n minus 1. So t raised to power n upon t, and yes, n minus 1 is already there. So t raised to power n upon t is what? 1 plus n x raised to power n upon t, just 1 plus n x raised to power n power 1 by n. So can you see, this is going to be 1 plus n x raised to power n 1 minus 1 by n. And of course, let's not forget n minus 1 was already there. So 1 minus 1 by n, option A is absolutely right. Option C is absolutely wrong because of the power. Can you see 1 minus 1 by n is my answer? Okay. All right. Clear? Now let's talk about this integration again. Ali Bada is saying, ma'am, can we put that as t power 1 by n as t? That's what we did. That's what we did, right? That's what we did. Can't you see that the whole thing is equals to t only? The whole thing, this whole thing is t. If the whole thing is t, then this thing will be t raised to power n. Same thing. If I remove this n over here, this will be 1 by n. Right? So this is t only, na? Alibada, you are saying same thing. I am also saying same thing. Okay? Alright, let us now move on to the next problem. Right? Now this looks like it is a very tough question. How many of you think that, okay, it is very tough question? Okay? How many of you think that this is very tough question? But this is actually not very tough. I won't say very easy, because the whole thing is this expression actually looks scary. X is also there, which is algebra is also there. Trigonometry is also there. Exponential function is also there. So this will blow our mind. This will scare us a bit. But what we can do is we can just try a bit, and a majority of us are good in substitution. Right? One thing we always do. Am I finding something? If I substitute this as t, a numerator becomes dt. So let us try doing that, and let us just figure out this x e raised to power sin x. X e raised to power sin x. If I put this as t, what will happen? Okay. Yes, for next time onwards, I'll be not keeping it white if you're facing any issues. Okay. All right, Chintu. Yes. So x sin x is coming out as t. So if x is there, x is constant, e raised to power sin x derivative will be e raised to power sin x derivative will be cos x, plus this time e raised to power sin x is kept constant, right? And the derivative of x is 1, and this is dx is equals to dt, right? Yes. So can you see that if I take e raised to power sin x common, It is going to be x cos x plus 1 dx is equals to dt. All right, clear? Okay. And one more thing. So that means if I put this as t square, this is t, so this is t square, so this is gone. This whole thing is gone. What about x? So if I have x in the numerator of dx, so that is going to be x upon x. If I multiply x by x, so what will happen? This whole thing, this will become t, right? This will become t. Okay, and this thing will become what? So this is t dt. So this is gone along with dx, right? And this t will be, so dt by t. So this is going to be dt by t 1 minus t square. Understood or not? Understood or not? Clear? So this is your t. T, it will go over here. So this t will be going dt by t. Okay. So this is also going. है ना? So x cos x plus 1 upon x dx is your dt by t. And this is 1 minus t square. Getting it? Now the integration of this is not very difficult. Okay. We need to integrate 1 by t and 1 minus t square integral dt. Right? Okay. And what we can do is, we have just right now, what we can do is, we can just write it in terms of partial fraction. So that is going to be a by t. A by t plus b upon 1 minus t plus c upon 1 plus t. Right? Partial fractions. So t 1 minus t square. So this is going to be a 1 minus t square. Right? Plus b times t 1 plus t. And plus c times I'm gonna get 1 minus t into t. And this is going to be 1. The moment I put t is equals to 1, minus 1 and 0, I'm gonna get the value of a, b and c. So the moment I put t is equals to 1, what will happen? Right? So the moment I put t is equals to 1, this will be gone. The moment I put t is equals to 1, this will also be gone, C option. Right? Okay. Let me just... Let me just remove this. Yeah. So this is plus c times t 1 minus t. So you put t is equals to 1. So on the left hand side, I'm gonna get 1. This is your 0. This is your plus b times the moment you put 1. So this is 2 plus this is your 0. Right? So clearly b is equals to half. The moment you put t is equals to 0, then what will you get? T is equals to 0 means this is also gone and this is also gone. Let us remove the denominator ka wo symbol because it might confuse you. Yes, the moment I put t is equals to 0, so these two will be 0. So a will be equals to 1. And similarly, what about C? The moment you put t is equals to minus 1, so t is equals to minus 1, this is also 0, this is also 0, and this will be minus 1 and minus 2. Right? Minus 1 and sorry 2. So C is going to be minus half. So C is minus half. So now what you can do is you can just try integrating. A is 1, so this is log of t. What is t? So log of x sine e raised to power sine x. Plus b times 1 minus t. So integration will be b is half. Plus half times log of 1 minus t. And minus 1 as well plus half because c is what? Minus half. So minus half log of 1 plus t. This is what we are going to get. So finally if I club them together, what do I get? Log of x sine e raised to power sine x. Minus half, what we are going to get is log of 1 minus t square. Alright, this is what we are going to get. Now this will be, okay. So now this is minus half. Minus half will go over here. It will become half. and this is log of x e raised to power sin x whole upon square root 1 minus t square x e raised to power sin x square, right? This is what you're going to get. But one more time, the question is saying half, half, half. So if I multiply 2 by 2 so that I retain the half, this 2 will go over here and it will become square. So this is square. This is also square. So this root will get cancelled out. So half x e sin x. Half positive half x e sin x whole upon, can you see 1 minus x e raised to power sin x square, or modulus is there, so option D, right? Either t square minus 1 or 1 minus t square, both will be fine, right? Both will be fine. Okay, shall I explain you this one more time? So that was very basic. The moment you get ABC value, you just have to integrate. So log of t we know. This is log of 1 minus t upon minus half. This is log of 1 plus t. Now you just have to club them together. So minus half. So 1 minus t, 1 plus t will be 1 minus t square, right? And we just have to rearrange it and match it with option D. Okay. All right. So D is absolutely right. Now we are having another question. This question, right? Very basic question. I always tell you, whenever you see square root, what should you do? So root x plus 2 should be equals to t. So that x plus 2 becomes t square. But we are looking for x minus 1 as well. What is x minus 1? So for that you have to subtract minus 3 on both the sides. So you are going to get x minus 1 is equals to t square minus 3. Okay. Now from here what you can do is you can right away differentiate. So dx will be equals to 2t dt. Now you just have to plug in the value. Dx will be 2t dt. Whole upon x minus 1 can be replaced by t square minus 3, and this x plus 2 will be replaced by t. So t and t are gone. So this is 2. Can you see that question, a square minus x square? I told you. So you can do minus sign common. So this is no need. 1 upon t square minus root 3 square. You can directly apply formula x square minus a square. So this is 1 upon 2 root 3 log of t minus root 3 upon t plus root 3. Mod plus constant. You just have to match. What is t? X plus 2 root. So log of root x plus 2 minus root 3 log of root x plus 2 plus root 3. Yes, 1 by root 3. Option A is absolutely right. This is wrong, this is wrong, this is wrong. Everything else is wrong, right? Only A option is absolutely right. Okay, right? Let me show you the formula. Shall I go back? Shall I go back and show you the formula? Okay, I already told you that we are going to do this. Yes, this formula 1 upon x square minus a square 1 upon 2a log x minus a upon x plus a. Right, this was the formula. I marked the star as well in the beginning of the session, and I told you as well this is important formula, right? And yeah, so this is it. Can you see x square minus a square? So 2 times 1 upon 2a log x minus a x plus a. So can you clearly see minus sign and plus sign? 1 by root 3. Option A is absolutely right. Okay, all right, clear. Now this question, I want you to attempt this question. I want you to attempt this question. I will give you 2 minutes to solve this question because I feel that you all can do this question, and 2 minutes is very much time. Okay, not 2 minutes, 60 seconds, quickly. 60 seconds. Let me just explain you. N to n plus 1, if you see n to n plus 1 gx, so that is n square. So minus 3 to 3, what you can do is minus 3 to minus 3 plus 1. That is what? Minus 2 plus minus 2 to minus 2 plus 1. That is what? Minus 1 plus minus 1 to minus 1 plus 1. Are you getting my point? This is minus 3 to minus 2. Minus 2 to minus 1. Minus 1 to 0. Then 0 to 0 plus 1. Then 1 to 2. Then 2 to 2 plus 1. That's it, that's it, that's it. Okay, so this answer will be what? So this is n square, lower limit square. So this is minus 3 square, which is 9, plus this is minus 2 square, this is 4. This is minus 1 square, then we have 1, then we have 0 ka square, then we have 1 ka square 1, then we have 2 ka square 4. So can you see 4 plus 1 is 5, 4 plus 1 is 5, 5 और 5 10, 5 plus 5 10, 10 plus 9 19. Okay. All right. 19. Easy peasy. Okay. All right. So 19 is the correct answer. All right. Yes. Now let's talk about differential equations, because we get some important problems from differential equations in your EAPCET examination. Go and watch your 2023 previous year question paper. You will understand. So in differential equation, we need to know how a differential equation is getting formed. From a curve, a differential equation is getting formed. What is the degree? What is an order of the ODE, ordinary differential equation? We need to understand. And solving differential equation by multiple methods like variable separable, right? And your linear differential, homogeneous, everything you need to know. Okay. All right. So over here, first of all, let's understand what is your differential equation, what is order, what is degree. So can you see that this is of the type of a polynomial? This is looking like a polynomial in your polynomial of a differential equation, right? The format I'm talking about. An equation having independent and dependent variables, differential coefficient of dependent variable with respect to independent variables. So can you see it will have dy by dx, it can have d2y by dx, that is, this is y triple dash. So it can have y, it can have y dash, y double dash, y triple dash. Okay. Then it can have powers of y dash or y, just like this. And it can have functions related to your independent variable, just like this. But what it cannot have? So it cannot have any negative powers. It cannot have any fractional powers. So powers clearly should be the whole number. If the powers are not in whole number, it is not a differential equation, right? What is order? What is degree? So order of a differential equation is nothing but, so you just see and observe. Maximum time your dependent variable has been differentiated. Here dependent variable is y, independent is x. So y, how many times your y, maximum number of times y is differentiated? Who is going to tell me? So can you clearly see this is thrice differentiated y triple dash. That means order of this is 3. And once you are done with the order, now you just have to focus on this term only. The power of this term, right? So the power right now is 1. Even though the highest power is 3, but no, we are not going to look at it. Highest power of higher order differential equation, degree is coming out as 1. Degree is defined for polynomial DE only, yes. So order is defined for any differential equation. But if you're talking about degree, it is very strict. So we have to figure out whether my differential equation is a polynomial differential equation or not. That means it should be in which form? Powers cannot be whole number and cannot be negative. Okay. You know the definition of polynomial, right? Okay. All right. Now variable separable method, very easy. We have done this already, right? What you have to do is you have to just shift all the terms related to x on the left hand side, all the terms related to y on the right hand side, and peacefully you have to just go on and integrate it, and you're done. You'll get the curve, or you'll get the solution of differential equation. This is your variable separable method. Okay. But we do have other things as well, like homogeneous and differential equation. Let us start solving the questions related to differential equation. Let's do that. So they actually not give you the exact proper difficult question, because differential equation involves differentiation, identification of differential equation, differentiation, integration, so many things. So what they will ask you is very basic things, right? And I cannot read this. This is directly from your EAPCET examination. So can you just read the options over here? So differential equation is what? So we need to figure out the identification they are asking. Okay. So let us identify it. So for that, the very first thing is they are saying is that a linear differential or not a linear equation? So let us first understand if it is a linear or non-linear. If it is non-linear, then we'll talk about homogeneous, right? So because 3 options I can see linear, high chances linear is there. So dy by dx, and obviously linear in y, linear in x. So it looks like it is not linear in y. It looks like it is a linear in x because the moment I calculate dy by dx, it is y square upon 3xy minus 1. No, this is not how a differential equation linear look like. Let me just show you how does a differential equation in y look like. So this is differential equation in y, where p and q are function of x. So dy by dx plus py is equals to q. I can't see like this. So it is not linear equation in y clearly. How does linear equation, so this is dx by dy, dx upon dy plus px is equals to q, where p and q both are function of y this time. So this is dx upon dy. Arey yaar. Yeah, this is dx. Okay. So dx upon dy, right? So now this is incorrect. Let us talk about this option linear in x. Let us rule out this option. So dx by dy, we are taking reciprocal of it. So this is 3xy minus 1 upon y square. Now it is actually solvable, somewhat solvable. So dx by dy minus time 3xy upon y square, so minus 3x upon y is equals to minus 1 by y square. Is it looking like this? So this is px. Yes, definitely. So minus 3 by y is your p, which is by the way function of y. So p, this is x. Okay. And what about this? Q is also function of y. So this is your q. Yes. So this is a linear in x. So option D is absolutely right. Okay. So this is how your questions will look like. The identification is very important. And you know what? If you want to solve any differential equation, what should be the first step? Identification. You don't have to solve it. Yes, one student has solved it, but in this question, they are not asking you to solve it. Okay. Another question from linear differential equation in X from 2023 only. All these questions are from 2023. Okay. All right. So this is from 2023 only. All right. Yes. So they are giving this as a differential equation. So this is linear differential equation in X. They are talking about integrating factor. So integrating factor of a linear differential equation in X looks like e raised to power integral of p and dy. So this is p dy. And they are saying that log y is your integrating factor. Now what we need to figure out is what p. Okay. All right. So basically what we need to do is, first of all, let us write the right hand side in form of e. So e raised to power log of y. If I write in this manner, e raised to power log will get cancelled out. Only log y will remain. So log y can be written down as e raised to power log of log y. Yes or no? Right? So e raised to power integral of p dy. That means this and this are exactly same. Integral of p dy will be equals to log of y, right? What we can do is differentiate both the sides. So p will be equals to, if I differentiate this both the sides, so this will be 1 by log y, and log y if I differentiate with the help of chain rule, 1 by y. So this is your p, 1 upon y log y. That means option D is absolutely right. Okay. All right. Option D is absolutely right. Okay. All right, and we have the last question of the day, which is, by the way, reducible to homogeneous. So for that, let me just show you something. Let me just teach you something. What is homogeneous? And what is reducible to homogeneous? So when your dy by dx is directly function of y by x, then you call it as a homogeneous. What you will do is y is equals to vx you will put. Do you differentiate dy by dx will be equals to x plus v dv by dx. Sorry, v plus x dv by dx. So v is constant, derivative of x is 1 plus x is constant, derivative of this is 1. And you need to proceed, right? This is your homogeneous. But reducible to homogeneous, what is that? So reducible to homogeneous means that first of all dy by dx will be equals to a1x plus b1y plus c1 whole upon a2x plus b2y plus c2. Right? And over here what you are going to do is reducible to homogeneous means that you have to plug in something. So x will be equals to x plus h, right? And y will be equals to y plus h, the y plus k. And the moment you do the substitution, what will happen is your dy by dx will be directly, first of all, dy by dx is small dy by dx, that is first thing. Can you understand this? The moment, so dy is equals to d capital Y. D small x will be equal to d capital X, right? So dy is equals to this. So both will be same, capital Y by capital X. What about this? If you substitute this, what will you get? So a1x plus b1y plus c1 will be there and whole upon a2x plus b2y. That's it. So this is what you're going to get. What do you mean? But ma'am, how do you obtain this? We don't understand. Directly, how can you write? So you have to nicely substitute small x is equals to capital X plus h, right? That's what you need to do. So capital X plus h, yes. So you have to substitute. So this will be a1x plus b1y and we are going to have a1h plus b1k plus c. So this term will going to get cancelled out so that we get rid of the constant. That's what the whole agenda is. We get rid of the constant and same goes with this. A2h plus b1k plus c should be equal to 0. So this is h and this is k. So the whole idea is that if you put h comma k in the numerator straight line and in the denominator straight line, both should be equal to 0. Let me show you with the help of this question. Over here, they can clearly see capital X is equals to x plus h, capital Y is equals to y plus k. Okay. All right, and again I told you the same thing, h and k. The moment you put h and k in here, first quadratic, so it's first linear, it should be 0 and it also should be 0. The moment I put 1 comma 2, so what will I get? 2 plus 6 minus 7, nahi ho raha 0, galat hai. 2 comma 1 if I put over here, 2 2s are 4 plus 3 minus 7, okay, it is happening 0, oh. All right, this is happening. So this option is correct. Can be correct. Sorry, can be correct because 2 comma 1 should satisfy this as well. So 3 2s are 6 plus, oh, it is going to satisfy this. So this is correct. Rest everything will not get satisfied because there will be a unique thing. Okay. All right. So this is the last question of the session, and now I just want to show you about the test series. So description mein there is a test series link given in the description box. That is your VIT EEE test series. I'll show you over here, right here. Just stay here, stay with me. Yeah, so can you see the description box right now? And students who are preparing for VIT EEE, so we have got this test series, and along with VIT EEE we are having many test series. You can just go here and you can just look for your test series as well. So it is for EAPCET examination as well, right? It is there is test series for actually almost every exam. BitSat we have, KCET, right? Okay, so yes, I guess you can just go ahead and right away buy the test series. 4,996 full length test series will be there for each and every exam. So you can go ahead and buy it, and you just need to scan this QR code, and we'll be bringing upcoming sessions for your VIT EEE examination. Do not worry. EAPCET examination, definitely we are going to bring more session, and some people are talking about J Advance exam as well. So we will be bringing a series dedicated to J Advance as well. Do not worry about that. We've got you covered. And on this note, this is me, Namrata, signing off. Okay.